So this assignment, which is related to particle physics and the accelerators, MCQs, multiple choice questions. The first 16 questions we did in the last session. So we'll start from 17 onwards, and after discussion of the MCQs, I will discuss the structured questions related to that. You can also use a chat to state the answer. We have isotope carbon, which is 14 and 6, is an isotope of a carbon. Which row of a table correctly shows the number of neutron and number of proton in the nucleus of carbon 14 and 6? So the neutron number, that is the nucleon number minus the proton number 14 minus 6, which is equal to 8. And the number of the proton are same as the atomic number. So option C will be the right answer. In question 18, in a linear particle accelerator or a linear, successive drift tubes increase in length. Like what happened? At the beginning of the start, the tubes are shorter. But with the passage, the length of these tubes increases and we accelerate the electron. But when it is passing through each tube, it will take the same time. Which of the following is the correct reason for increase in length? So why we are increasing a length? The time spent by the particle in the successive tube increase, that's wrong. Because what happened, the time, it will take the same time. Speed is equals to distance divided by time, so length of a tube divided by time. So time is length divided by speed. So what happened as the length is increasing, the speed will also increase, but the ratio will remain constant. So which of the following is the correct reason for increasing the length? The time spent by the particle in successive tube increase, that's wrong. The time spent by particle in successive tubes stays same, that's true. What about C? The particle gain more energy in successive tube. Actually, the particle gain equal amount of energy. It's not like particle gain more energy in successive tube, it's gain equal amount of energy in successive tubes. And the frequency of accelerating voltage can be increased, that's wrong, if the frequency remain constant. Like the change in the terminal every second will remain constant. Otherwise, maybe this particle, example, first say we are using an electron. So when this electron is accelerated, like first the top is positive, negative, positive, negative, positive, negative, positive, negative. What happened? This electron is accelerated. Once it enters the tube, the terminal changes, become negative, positive. So within the tube, there is no resultant electric field. That's why the particle does not accelerate within the tube. So it will move with a constant speed. Then the moment it comes out from one tube, it will experience the electric potential from the other tube and that causes it to accelerate. So between the tubes, it is accelerating. Within the tube, it will travel with the same speed. So particle gain more energy in successive tube, that's wrong. Like particle is actually not gaining in the tube, it does not gain any energy. Like between the tubes, it is gaining energy. An equal amount of energy it gained between the tubes. Next is question 19. A proton and electron with the same velocities enters the magnetic field which is perpendicular to the direction of their motion. The field is into. Which of the following diagram represent the motion of the particle? So first, we'll use a left-hand rule. Our index finger should point in the direction of a magnetic field. So which the index finger should point into. The first finger or index finger should point into. The second finger represents the direction of the particle motion. That is, in this case, it is moving up. Where your thumb will point, when you apply the rule, the thumb is automatically pointing towards left-hand side. So if there's a positive particle, it will deflect towards left. So first, why A cannot be a right answer? Because electron is negative particle. Here it cannot be because electron is reflected left, but it should be positive particle deflected left. So either C can be an answer or D. Then when we check the momentum, the radius of the curvature is proportional to momentum. Even though, as I mentioned, both are moving with the same velocities, but they have different mass. Proton is massive, like having more mass compared to electron. So the momentum of the electron will be smaller as it is having, it's a lighter particle, where momentum of the proton will be higher. So if its momentum is high, the radius of curvature will, it will have a large radius of curvature, it will deflect less. There will be deflection, but small deflection. That's why here D it shows that there is a large deflection, but A it shows there is a C it shows it is a small deflection. That's why C should be the right answer. In question 20, in Large Hadron Collider, the Large Hadron Collider is designed to accelerate proton to a very high energy for particle physics experiment. Very high energies are required for what? Because basically when we use a very high energy, we can produce particles with more mass, massive particle, as we have the formula E equals mc square. If the kinetic energy increases, so we can produce particles which are having high mass. So to annihilate hadron, annihilation means when particle and antiparticle collide, mix with each other. That's not, even we don't need too much energy for annihilation, as the opposite spins and the charges are also opposite. So particle and antiparticle will collide or hit each other. Collide hadrons, not only, even we can use a low energy to collide hadrons. So that's not the valid. So create particle with a large mass, as we have like more kinetic energy for the particle, so greater amount of energy change into mass. If more energy, it means it can produce massive particles. And to produce individual quarks, that's also not the valid reason. In question 21, an electron which is having a momentum of 9.1 into 10 power minus 24. The kinetic energy of the electron is, so how we can work out this? The relation, there is a relation also between the kinetic energy and the momentum. Like kinetic energy is half mv square. If I multiply and divide this equation by m, so it will be m square v square over 2m. That is kinetic energy. M square v square is actually the momentum square, so we can say p square over 2m is equals to kinetic energy. So p square over 2m is equals to ek. So we need the kinetic energy, we have the momentum. So that will be 1.9 into 10 power minus 24 square divided by 2, and the mass of electron as a constant, it will be there. So that is 9.11 into 10 power minus 31 kg. So when we divide, because the mass should be in SI unit, so when we divide, we'll get 2 exponent minus 18 joules. So B will be the valid answer. In question 22, two particles are there, X and Y were created by the decay of a lambda particle at O. So as you don't see the track of lambda particle, decay of a lambda particle at O, so we don't see any track. Because in a charged particle track detector, the uncharged particle does not have any track because they are not causing any ionization. So the lambda particle does not have any track, even though it was moving, but no track for lambda particle, which gives an evidence that the lambda particle should be neutral. So which of the following is a valid conclusion from the information? X is negative charge, Y. We can identify X is negative, Y is positive if we know the magnetic field, but we don't know the magnetic field. That's why we cannot say anything. The magnetic field is into the paper. We can identify magnetic field is into or out of the paper if we don't know the nature of the particles. But here we don't know the nature of the particle. That's why we cannot identify the magnetic field as well. So only valid option that lambda is a neutral particle. And what is the conclusion? Like how we conclude this? Because there is no track for lambda particle till point O. Which of the following is the correct statement about the momentum? So the total momentum is conserved. The momentum before collision should be equal to momentum after. The momentum of X is equal to momentum of Y. So momentum is a vector quantity for the momentums to be equal, and the curvature of the track is also different. Like if they were having the same momentum, they should have the same curvature as well. But it does not look they have the same curvature. So it means we cannot say they have the same momentum. The total momentum of a system is zero. That's also wrong because the particle X and Y are moving. So it means the total momentum before the particle, like example, a lambda particle decay. So lambda particle was also moving. If there was a stationary lambda particle and that decays, so one side it will produce X, another side it will produce Y. So the total momentum is not zero. The vector sum of momenta of x and y must be equal to lambda. That's true. Like if we add the vector sum of x and y, which is after the decay, and lambda is before decay, so that should be equal. Because whenever particle interaction or collision happen, then momentum should be zero. The vector sum of momenta of x and y must be equal to zero. That's wrong. Why? Because if initial momentum is not zero, the final cannot be zero. This statement, the vector sum of moment of x and y must be zero. If the lambda was stationary, so if x is moving towards right, y should move towards left. And when we add them, one will have a positive momentum, another one negative momentum, so sum will come out as zero. But this is only the case if the lambda particle was stationary. But how we conclude lambda is not was not stationary as the lambda was moving, and it would create two particles, so it means that because the final momentum of x and y is not zero as they are not moving in an opposite direction, so initial momentum should not be zero as well. In question 23, a moving pion decay into two particles y and z. The decay occur at point x. The particle detector in a particle detector and a track observed as shown. Which of the following is a valid conclusion from these tracks? Again, you can see that there was no track for till this point. So what this given evidence that first how we identify this is a moving particle. If it was a stationary particle, then if two particles are generated y and z, they should move in opposite direction to conserve the momentum. But in this case, because two particles are having a different tracks, which shows like they're moving and they have the resultant final momentum. When we add them, the sum of momentum will have some value. So it means initial momentum should also be should have some value. So and till this point we don't see any track. So what is this evidence This gives an evidence that there's a neutral particle here. Momentum has not been conserved. That's totally wrong. Momentum will always be conserved. The pion is a neutral particle in this case. That's true because as a pi, this is a track. What happened is a moving pion decay into two particles. So this moving pion does not have a track which shows the moving pion does not have a track which shows that these particles the particle was neutral. And Y and Z have different masses. We don't know where, like, because they may have different masses or they may have different speeds. Actually, the track, the curvature of a track gives an idea about momentum, not only mass or not only velocity. It's a product of mass and velocity. And Z is negatively charged particle. That, again, without knowing the magnetic field, we cannot conclude anything. Question 24. The diagram shows the path of alpha particle is being deflected by a nucleus of an atom. The point P on the path is a point the closest approach by alpha particle to the nucleus. Which of the statement about the alpha particle on this path is correct? It accelerate, its acceleration is least as p. That is the maximum acceleration because it is also changing a direction. The speed is least because what will happen when the alpha particle is moving? So it slow down and then it will change the direction, move in opposite. So B is the right answer. Its total energy is greatest as P. So if its speed is lower at P, the total energy will also be. And the momentum is greatest at P. Again, because if momentum is a product of mass and velocity, so velocity like is a minimum, the momentum should also be minimum. So and speed is kinetic energy, which is half mv square. So speed is minimum, the energy will also be minimum. In question 25, which of the following is not a valid conclusion from Rutherford alpha scattering experiment? So the Rutherford experiment is there. The nucleus contains most of the mass of an atom. That's true. The nucleus contains proton. That is not like nucleus is charged. That is a valid conclusion, but not nucleus contain proton. Even though nucleus contain proton, but the valid conclusion from the Rutherford experiment is just a nucleus contain charged particle, but it's not about the proton. Or a nucleus is charged. The nucleus must be charged. That's true. A nucleus is very small compared to atom. That's also true. So B is not the valid conclusion. Like it does not say that there is a proton inside. It says that the nucleus contains charged particle. In question 26, the rest mass of a kaon is 494 mega electron volt per c square. What is the mass in kilogram? So mass in mega electron volt per c square is actually energy in mega electron volt. So it is 494 mega electron volt. First, we convert the mega electron volt into electron volt. So it will be 494 into 10 to the power 6 electron volt. Then 494 into 10 to the power 6 electron volt will convert into joules. We have 1 electron volt is equals to 1.6 into 10 to the power minus 19 joules. So this many electron volt will be X. Cross multiply. We'll get the energy in joules. And then we'll use the formula E is equals to mc square. So after getting the energy in joules, which is 494 into 10 to the power 6 times 1.6 into 10 to the power minus 11, that is the energy in joule, divided by speed of light square, 3 to the 10 to the power 8 square. So this will give us a mass in kilogram or a rest mass of this particle in kilogram. So C will be the right answer. Question 27, a student writes the following equation for a decay of a neutron. Which of the following conservation law is violated by the equation has written? So this equation will check which law is violated. Baryon number for each quark it is 1 by 3 and for empty quark it is minus 1 by 3. And baryon number because neutron contain 3 quarks, so 1 by 3, 1 by 3 and 1 by 3, so it is plus 1. Proton is also plus 1 and electron and anti-electron neutrinos, like electron neutrinos and leptons, so baryon number is valid. We have to check which is violated, like which is not balanced. For this is neutral, this will be relative charge plus 1, minus 1, and electron neutrino does not have any charge. So charge is also in the energy. There is nothing mentioned related to the energy. Definitely energy or momentum will be conserved. Then we check the lepton number. For lepton number, each lepton is plus 1 and anti-lepton is minus 1. So neutron and protons are baryon, so they don't have a lepton number. Electron is a lepton, so plus 1, and electron neutrino is also a particle because all the particles, all the leptons have like a 6 leptons, electron neutrino, tau neutrino, and neon neutrino. They all have a lepton number plus 1, remaining will have minus 1. So lepton number is also plus 1 here. So lepton number is also conserved. Sorry, lepton number is not conserved, rest all are conserved. So D will be the right answer. Then a nucleus which is X 69 and 30 emits a beta particle which row? So it's a negative, beta negative. In a beta negative, what happened? A neutron breaks into proton and electron, and to conserve lepton number, there will be anti-electron neutrino. So neutron number decreases, where proton number increase by 1, but the nucleon number remains same because this is a sum of neutron and proton. One neutron decrease, one proton increase, so sum remains same. But atomic number increases by 1. So it was 30, this should be 31. And nucleon number does not change at all. So 31 and 69, so C will be the right answer for question 28. Question 29, kaon can decay into several ways. Which of the following decay is not possible? So basically we have to check the conservation of the charge, conservation of lepton number, baryon number. So the best thing is you start with the conservation of the charge. This is on the left hand side, this is neutral, plus 1, minus 1, and electron neutrino or anti-electron neutrino does not have any charge. So charge is conserved for A. What about B? 0 is there, plus 1, 0 and plus 1. Again, you can see left hand side is 0, but right hand side it is plus 2. So it is not possible, like charge is not conserved. Here plus 1, 0, plus 1 and 0. So it is conserved. Plus 1 and 0. So it is also conserved. So B, the charge is not conserved. That's why this decay is not possible. So first we start with charge. Then we check a baryon number, then lepton number. And in case some of the like decays or interactions may involve the strange particles, so we call it a strangeness number. For every strange particle, it is plus 1 and anti-strange is minus 1. The diagram shows the drift tubes at the start of a linear particle accelerator. At the end of a linear particle accelerator, the drift tubes are at same length. Which of the following is the reason for this? Like at the last, we don't have like too much variation in the length. It's approximately same. Because the reason for changing a length is as the speed is changing, the length we change. If you are keeping the length same, it means the speed will not change. So frequency of accelerating potential difference increase, that is not increase, it remain constant. The particle are no longer gaining energy. The the rest mass of the particle is increased. This is only valid if the particle moves close to speed of light. The speed of the particle is no longer increasing. So, so valid conclusion, like which of the following is a reason for that? The speed is not changing. Particle can gain energy as they are moving. So the particle may change the position, so they gain energy. But the speed of the particle, they don't gain kinetic or kinetic energy is not changing. That's why at the last, these tubes are of same length. But in the beginning, first we have a shorter one, then a bit longer, then much longer tube is there. So why there's a difference in the length? So that the particle is accelerating. But after certain tubes, the length of the tube is constant, shows that the particles are not accelerating or changing the speed. So D will be the right answer. This is an electron diffraction. A beam of electron is directed at a sample of a crystalline material, and a diffraction can occur. As you can see, this can be observed as a set of concentric circles on a fluorescent screen shown on the photograph. Which of the following change would decrease the diameter of these circles? So, if you want to reduce the diameter of these circles, like we want greater amount of diffraction to occur, or we want to reduce, we have the formula lambda is equals to h over mv. So if we increase the momentum of the particle, the wavelength will decrease. And shorter waves diffract less than, like example, if the gap size is bigger compared to the wavelength, as a result, what will happen? There will be diffraction, but small diffraction will happen. So the question is, which of the following change would decrease the diameter of the circle? Use a crystal with a smaller spacing. So if we use a smaller spacing, means narrow gap, more diffraction. So in that would increase the diameter of the circle, not decrease. Use the screen further from the crystal. That will also again increases. Like if the screen is far, the size of the rings will also increase. Use electron with greater momentum. If the momentum is more, the wavelength will be shorter. And if the shorter wavelength, it will diffract less. So these circles will, the diameter of the circle will be smaller. And if you use an electron with low speed, so low speed electron means less momentum, greater wavelength. And if we have a longer wavelength than the gap size, what will be the result of that? There will be a maximum diffraction. So C is the right answer. In question 32, the isotope of polonium is there, which is 84 and 209 decay by emitting out alpha particle. Which of the following correctly shows the nucleon in the isotope? So when there's an alpha decay, the nucleon number decreases by 4 and atomic number decreases by. So this will be nucleon number minus 4. That will be 205 and this will decrease by 2, so 82. And there will be an alpha particle. So 205 and 82. So C will be the right answer. Sorry, it's about neutron. So after getting the particle, then we find a neutron. Like how to find neutron? Which of the following shows a nucleon in the isotope produced? So how to find number of the in this one 205 minus 82, which is 123, and the proton is 82. So 123 neutron, I thought it was a nuclear number, but 123 neutrons and 82 protons will be there. In question 33, which of the following decay for a pion is not possible? So when the pion is decaying, which is not possible for it? Here, the first one, like when you check the conservation to gamma particles, so this is neutral, charge is conserved. Here charge is also conserved, but this one charge is not conserved. Like neutral particle, positive, and this is neutral. So charge is not conserved. So that's why C is the right answer. So first, whenever we check start with the conservation of charge, then baryon number, then lepton, and at the last, if there is a strange particle, we check the strangeness. The table shows the 6 types of quarks and their relative charges. Which of the following shows a possible quark composition of a baryon which is having a charge of minus E, like same as the charge of electron? So when we write the charge here for a charge, it is 2 by 3 plus 2 by 3 and anti-strange. Strange is 1 by 3, anti-strange will, so the sum will be 3 divided by 5, so 5 divided by 3, it's not a whole number. When we check down, it is minus 1 by 3, strange is minus 1 by 3 and another strange also minus. So when you simplify 3, minus 1, minus 1, minus 1, which is minus 3 by 3 or it's equals to minus 1. So B will be the right answer. And for this one, up and down, so 2 by 3, 2 by 3 and down is minus 1 by 3. This will, when we simplify this 3 is an LCM, so 2 plus 2 minus 1, that will be 3 by 3, which is equals to plus 1. So this will give plus E, not minus E. And NT up, so minus 2 by 3, minus 2 by 3, and this is minus 1 by 3. It will be minus 5 by 3. Okay, that's why this is not done. So B is the right answer.